Hello, I'm Patrick Thompson. I'm a program manager in the WinFS team, and we're in the process of building the future storage system, as we sometimes call it, for the Longhorn operating system release. Actually, WinFS stands for Windows File System, and I'm going to go through a few slides that show you how the schema side of WinFS works. I'm going to focus on the schema side of WinFS, although there are many other aspects to it. But we'll be mostly looking at how the schemas themselves work, and then a little bit about how you extend schemas and some examples about how schema extensibility hangs together. So looking at the first slide, we'll come around to talking about what exactly a schema is, and then get on to some examples of schemas themselves. So we start with the question of what exactly is a schema. And we can look at it in terms of two sort of broad headings. The first is the idea of a schema as being a collection of type declarations. So in this sense, a schema is things like properties, relationships, these things which you may be familiar with, and some other things which may not be so familiar. The idea of an item, and we'll see as we go through the presentation that items have a very distinct structure to them, and extensions, which are things that you add on to items that also have a very distinct structure to them. But anyway, for the moment, we can think about a schema as just being a collection of type declarations. So it's very much like a CLR namespace, if you happen to be familiar with those ideas. What you get from a schema is two things. Firstly, there are structures in the store, that is the actual things that we put the data into. And then secondly, there are APIs that allow you to access those structures. And you can think of this visually as shown by this little diagram, in which you have a schema as a document being fed into a schema compiler over on the left here. And that then produces structure definitions, which is what is used to define the actual store structures, and API classes, which eventually end up with something like API assemblies that you can include into your programming environment and use in order to program against the store. There is also, you'll notice, the ability to add in some logic to the APIs as a sort of a secondary step, so you can provide behavior along with the schemas. So another way to think about schemas is to look at what schemas will actually come with Windows in the Longhorn timeframe. And you can think of these under two general headings. Firstly, there's the idea of user data, and these are schemas that are to do with things that users work with directly. So these are things like contacts, documents, messages, locations, and so on. And secondly, there is this idea of system data. So these are things that applications use and that the system itself uses in some way. And here we have things like applications, principals, this is things to do with security, configuration, and so on. So there are these sort of two general headings. And at least at the present time, we have something like about 30-odd schemas which are part of the early betas that are being put together as we speak. So the schemas come in various layers, if you like, and you can think of the base schema, as I'm titling it here, as being this kind of underlying layer that defines the fundamental concepts which you work with in working with WinFS. And in the base schema, there is a thing called the item type. And the item type is this sort of basic type from which most of the data derives, or on which most of the data is based. So the item has 5 fairly simple properties. The notion of when it's created, the notion of when it was last modified, a display name, and whether it's file backed or not. And most importantly, it has this idea of an item ID. So the item ID gives you an identifier for an item, and everything that is an item, and things like contacts and locations and applications and all these other things that WinFS knows about are represented as items. All of these things have these basic properties, most especially the notion of an item ID. So the item is one of actually 4 basic types that are defined by the base schema, and from which everything else flows. It provides the basic conceptual structure of the WinFS type system. The second type that I'm going to talk about is the relationship type. So relationships in WinFS are types, the same way that things like items are types. But the relationship type has the special characteristic that it associates one item with another item. And this is represented literally in the schema as a type with a reference to one item, which is the target, and a reference to another item, which is the source. And you can see this sort of represented in the way that the relationship is defined in the diagram, and where you have this notion of the source and target item ID. Now, the other most important property here on a relationship is this notion of a mode, which is the second property defined in the list of properties on the diagram there. And the mode actually takes three values. It can be either embedded, reference, or holding. And the embedded relationship basically implies that the thing on the other end of the relationship is embedded inside the thing that the relationship starts from. The holding relationship implies that the thing that the relationship starts from, in some sense, owns the thing on the other end. And the reference relationship basically means that it's a pointer. It's just a very free pointer to the thing on the other end of the relationship. So this basic notion of how relationships work is defined as a part of the base schema. Another important type is this notion of a nested type. And nested types are types that are used for properties. So you can't use either an item type or a relationship type as a property type. They have special structures and behaviors that make that impossible. Whereas if you want to have something like, say, for example, an address with a state, city, and zip codes associated with it, and define that as a type on a property for, say, a person to represent where they live, then you'd use a nested type in order to do that. So you'd derive an address type from the nested type in order to represent that. Then finally, the fourth type that we have here is this extension type. And the extension type essentially gives you a bag of properties, a strongly typed bag of properties that you can add on to an item in order to provide additional information that either doesn't fit in with the way that the item is defined in terms of its subtype structure, or that it's something that was just not thought of at the time that the item was defined in the first place, and that somebody wants to add in at a later date. So there are some subtypes in the base schema. Notably, there is the folder type, which allows us to organize items into a folder structure. And you'll see that there is a relationship between folder and item called folder member. And this, in fact, is a subtype of the relationship type. So WinFS folder, the WinFS folder member type is a relationship. And this relationship essentially defines which items are present in a given folder. There's also this thing sort of stuck on the side here called generic file, which is a mechanism for us to represent information that is present in a file, but for which we don't really have an item type. So as you'll see, we have a variety of different basic types that are understood by the system. And sometimes there are files that just contain strange things that we don't particularly want or know how to surface in WinFS. And where these things arise, we represent them as a generic file. So I mentioned earlier that the schemas are arranged in layers, if you like. There is the base schema as the sort of the bottommost layer. And then there is a layer above that, which is this notion of a core schema. And the core schema represents fundamental ideas around how we will organize the items within the WinFS store. So the core schema has both relationships and types defined within it. And there are a couple of basic relationships defined within the core schema, notably the component relationship and attachment relationship. So we will see various subtypes of the attachment relationship that define special types of attachment. Say, for example, the attachment relationship between an email and the things attached to it, or the attachment relationship between a document and the things attached to it. And those two types of attachment have different behaviors and different characteristics to them, so they need to be subtyped. They can't really be represented by the same thing. But the fact that they both represent attachments is also an important idea, and is what is aimed at by this attachment notion. I'm just running quickly through some of these things. The core schema defines the idea of a location. So this is a geographical location. It's something that actually has latitude and longitude, if you like, and which could have things like an address associated with it. But one geographical location may have multiple addresses. So think, for example, of one Microsoft way. There are many ways that you can address that from a postal point of view. The location also has the notion of a location parent, allowing us to represent the idea that one location is contained inside another location. Then we have things like contact. Contact is a very rich object, has many things associated with it. Many relationships terminate on the contact type. So contact have presences, which is where the contact is at the moment, or what the contact is interacting with at the moment. Contact roles, which is a source for many subtypes, which is things like employment, for example, and friendship are considered to be contact roles. And contact locations is various relationships between a contact and a location. Event represents something that happens at a point in time. So these are things like appointments, for example. Message is a wrapper for a message of some kind, and should be careful not to confuse message and document, and that a message is not a document. It may be a wrapper for a document, but it is not itself a document. It's a vehicle for transmitting information. A task is something that somebody does. A document is something that can be rendered. So documents have various subtypes. So things like the standard Office documents, such as Word documents, spreadsheets, and so on, are considered to be types of documents. But so are things like videos, audio, these kinds of things. So there's a large subtype tree under document that represents the various types of document that we have in the system. And then device is something that can, a physical thing that can do things. So like, for example, a computer or a printer or a transmission device of some kind. So we now move on to the subject of how the schemas sort of hang together as a whole. And one way to give you an idea of this is just to actually look at a diagram that represents the schemas as a whole. So what I'm going to do is to switch to a Visio diagram, which provides an overview of what the schemas look like. So the diagram is actually vast. If you print the whole thing, it comes out, even at a very small font, using an 8-point font, it comes out at something like a piece of paper about 20 foot wide by about 4 foot deep. So it's a huge thing. What I'm going to do is just navigate around it, just to give you some idea of what the distribution of the types is and sort of how things hang together. So this is the Visio diagram that has been extracted from the schemas as they are at the present time in the where we are in our current point of development. And you should understand actually that what we're doing is working on these things over time, and schema development is an ongoing process, and we expect to have to change these things really right up until the end. Obviously changes will get harder as we get further into the development process, but as we see new requirements, new developments, there is no question that these schemas will change. However, looking at what we have today, really what I wanted to give you a feel for was the general distribution of the types across the schema as a whole. Now, if you remember going back to the discussion of the base schema, there are actually 4 basic types there. There's the item type, the extension types, the nested types, and the relationship types. And all of these are represented in this diagram. What I'm doing here is I'm using the Visio pan and zoom facility to zoom around the schema, and the little red box here is focused on this big pink box, which is the actual item type. The colors, incidentally, are significant in that the boxes that belong to a particular schema all have the same color. So in this case, you can see that the item type sits at the root of this fairly large hierarchy that spreads across just about the whole page, with some parts of the hierarchy, the stuff that we have over on the right here, being quite deep, other parts of the hierarchy being relatively shallow. And in some cases that represents some measure of immaturity in the schemas. In some cases it's just a question of that the various domains are different and result in a different structure. So if we move around this diagram a little bit, you can see, if we go over to this side, this is actually the root of the extension type. So the extension type tree right now is actually quite small, and we expect that the extension type tree will grow quite substantially over time. And in fact, I would expect that in time the extension type tree will be larger than all of the other trees. So the extension type tree has underneath it things like, for example, the principal type, which we like to be able to attach to a variety of different other types. So you can't really use subtyping in order to represent principals, because things like both computers and contacts need to be principals, and it's more convenient then to be able to attach this set of principal properties on the side of a contact or a computer. So moving over to this portion of the diagram, you can see here this is the root of the nested type hierarchy, and nested types are basically simple types that are attached to properties. So these are types that have themselves have properties and allow you to sort of have a property which is a structure of some kind. And so nested types come in various forms. We have, for example, the concept of an e-address as being a nested type, where an e-address is an electronic address and has information on it such as how the person wants to be known when they're using that electronic address and what the actual textual form of the address itself is. And then moving down to the bottom of the diagram here, this very large flat tree at the bottom is the relationship hierarchy. And the relationship hierarchy doesn't have very much by way of type structures under it, although, again, I expect that over time these type structures will become rather more elaborate as we move on. And just finally, over on the right here, there is actually a key for the whole thing, which explains the conventions used in representing this diagram. And you will find the diagram out on the web at about the same time that this talk becomes available. So switching gears in, now we're going to move away from the discussion of particular schemas and look really more at the question of how you can extend the schemas. In fact, how you can extend WinFS as a whole. The schemas actually permeate just about every aspect of WinFS. And so in any way that you work with WinFS, you will almost certainly be working with schemas in some form. This particular slide actually outlines all the various different techniques that are available to you in order to extend WinFS. So you can extend things such as the API, which is what is represented by the stuff at the top of the diagram there. You can extend through working with the shell. You can extend through working with synchronization, with the info agent, and by working with various different file formats and importing stuff into or promoting stuff into WinFS out of file formats that you can work with. Now, what I'm going to talk about here, though, is just the first two types of extensions here, which is the notion of extending and relating Windows types and the idea of actually building your own types. So looking at ways to extend the store. Now, I don't want to put you off somewhat, but you should be aware that actually extending and defining schemas is not a trivial exercise. It's something that has to be taken with some caution, in that it's very easy to do things wrong with schemas, and getting the schemas right is quite a major undertaking. So in many ways, the best thing to do in working with schemas is actually not to define a new schema at all, but to look around and see if you can use somebody else's schema. The chances are, if we've done our job correctly in terms of the schemas that we ship with the operating system, that we will provide at least a framework for whatever the information is that you want to put into the system. And so it's very important to look around and see if you can, in fact, use some existing schema rather than creating a schema of your own. And the Windows Store has a notion of namespaces of how the types of various types and instances are organized within the store. And so it's possible for you to sort of create your own little item universe in which you have a set of items of your own that have meaning that you attach to them, but that nonetheless simply use types that already exist. So the first and most sensible thing to do in working with a schema is don't invent a new one, just use one that's already there. You can also use things like the notion of keywords in order to add information into the system without introducing new types. And in fact, one of the features that will be available in the final releases of WinFS is the idea of dynamic properties, where you can actually add in properties with names and types associated with them, but without actually having to modify the schema at all. So there's a number of things you can do in order to work with WinFS and to add in new types of information without actually having to work with the schemas themselves. However, if you do decide to extend the schema, there's, again, a bunch of things that you can do. So you can add in item extensions. So these are new types of items that are subtypes of the item itself. You can add in nested type extensions, so that you can subtype nested types and or introduce new nested types of your own. And you can, of course, completely design your own schema. You're free to come along and using the basic 4 types, the item type, the nested type, relationship type, and extended types, you can define your own schema structure and do whatever it is that suits your purposes in that area. So I'm going to run through a quick little example of how this might work. And this is a little scenario in which we have a personal injury law firm that wants to track information about cases and documents associated with them. I'm just going to run through a few of the thought processes and steps that you might take in order to establish this schema. So the first thing to do in working with the schemas is to really look very carefully at what already exists and to evaluate what you can attach yourself to. There's two very good reasons for this. One is the fact that it saves you the trouble of having to design this stuff yourself, and the design is, as I said, not a trivial exercise. But the other and really much more significant thing is that if you work with types that already exist in the system, then other things that work with those types will understand your data. So in this particular case, we're looking at using the idea of a document and a contact, which are defined as a part of the system. So the system comes with an intrinsic notion of what a contact and a document is. And if you work with those notions of contacts and documents, then all the tools and paraphernalia around Windows that understand those things will understand your contacts and your documents as well. So this is a huge advantage in terms of how your application will work and how it will fit into the environment as a whole. So there are some things, however, which just don't quite fit, and in this case, the idea of a case. So this is a legal case, which is peculiar to this particular domain, doesn't really fit with any of the core types, and so what I've done here is I've basically just defined a new item type called legaldoc.case, which is just something completely new so far as the system is concerned. It doesn't actually fit in with any of the existing types. However, I can define relationships which relate it to the existing types. So I have this idea of a LegalDoc client and a LegalDoc case documents, which ties my case item into the world that is understood by various other applications that exist within the system. And of course, I can establish whatever properties I need on case in order to make it work. And then I also have introduced this legal document extension. And what I'm doing here really is I'm allowing myself to add properties onto document without actually having to modify or subtype document itself. So in this way, I've basically added something on the side so far as document is concerned. I've introduced this notion of a document as being a legal document. So I can take, say, for example, a video or a photograph or a deposition of some kind, add this legal document extension to it, and then be able to track and understand these documents in the context of the application that I'm working with. So that's roughly how, a rough, short picture of how a schema extension might work and how you would go about working with the schemas that we ship with the operating system. So some sort of key takeaways here. Firstly is the idea that really, so far as schemas are concerned, WinFS is all about schematized data. That it's very important to understand the model, that sort of big Visio diagram, to have an idea of what the overall topology of the schema is in order to work with WinFS. There are various basic Windows schemas, the base schema, the core schema, and so on and so forth. And this overall schema structure is again something that's very important to understand, so that you have an idea of what the topology is, the sort of the conceptual landscape is that you're working in. And finally, this idea of extensibility, being able to add your own stuff, understanding your requirements and the various extension mechanisms that are available to you. Well, that's about all I've got to say for now. Thanks very much for taking the time to look at this. There's many aspects to WinFS. It's quite a large and complicated system, and schemas are just one of them. There are other things around notifications, the file property promotion aspects of it, the synchronization aspects of WinFS, the API that WinFS has. And I would urge you to look at and understand those in order to understand how the whole thing fits together. What I've shown you today is actually very fundamental to WinFS. The schemas are a major part of how WinFS works, but there are these various other things that you ought to have a look at in order to understand the system as a whole. So good luck working with WinFS, and I hope you have much success in using it.